Welcome dreamers, this is Ravindra Thube, faculty at BYJU'S Exam Prep and you're watching Daily Dose. Let's understand that when we talk about metal forming, there is very important concept which is ignored almost most of the times, and most of the times question asked in a GATE examination will talk about that concept. We know that in a simple fundamental, that concept is called as instability in tension. Instability in the tension. We know that, sir, if I ask a simple question, what is the value of a stress? You will say that what silly question you are asking, sir. Stress is exactly equal to a load force divided by a cross-sectional area, which means that the force is exactly equal to a stress multiplied by a cross-sectional area, right? Cross-sectional area. Suppose I am selecting one cylindrical rod and applying uniaxial tensile force. The original cross-section area is A0. As soon as I am applying force, can I say length will keep on increasing and the diameter will keep on reducing, which means that, sir, cross-section area is going to reduce. If the cross-section area is reducing, can I say that load has to also reduce? But we know that for further and further plastic deformation, actually more and more load is required, which means that reduction in the cross-section area will be always compensated by increasing the value of stress, which means that the rate of increase of stress is greater than the rate of decrease in cross-section area, or reduction in cross-section area is compensated by increasing the value of stress. But this can only happen up to certain point, and that point is nothing but called as a neck point. Up to the neck point, the compensation of reduction in area will take place by increase in the stress. But at that point, sudden reduction at neck point, sudden reduction in cross-section area cannot be able to compensate by that much increase in the stress, and therefore instability sets in. That point is also called as a geometric softening. That point is also called as what? Geometric softening. Therefore, at neck point, at maximum load and at a point of instability, rate of reduction of cross-section area is greater than rate of increase of the stress, and therefore instability sets in and the body will fracture after a certain particular time. And mathematically, it has improved that. What it has improved that? Mathematically, it has improved that at a neck point, at a maximum load point and at a point of instability, my value of a true strain epsilon is exactly equal to strain hardening exponent. Epsilon is equal to small n, and this is utilized while solving number of numericals. How? Let's see that. Very interesting question was asked, right? Fine. Let's see his question. A true stress in megapascal versus true strain relationship is given by sigma is equal to 1020 epsilon raised to 0.4. The cross-sectional area at the start of the test is 100 mm square. The cross-section area at the time of necking is. So neck formation whenever is happening, we are interested to calculate a stress at that particular point or cross-section area at that particular point. We know that, sir, original cross-section area A0 is exactly equal to 100 mm square, right? And let's say that, sir, the cross-section area at the time of neck, right? Necking cross-section area, or I'll say that not A0, it has to be, sorry, not D area we are interested to calculate. And we know that the strain hardening equation is sigma is equal to 1020 into epsilon raised to 0.4. If I compare this equation with strain hardening equation, sigma is equal to K into epsilon raised to n, can I say that small n value will be exactly equal to 0.4. Small n value is exactly equal to 0.4. And we know that at neck point, can I say true strain is exactly equal to small n, that is 0.4. So at a neck point, we are getting the value of strain, and we know that at a neck point this is equation. So what is the equation of true strain? Ln A0 by A1, that is A0 divided by neck cross section area. Yes, so therefore epsilon is 0.4 is equal to Ln original cross section area is 100. We are interested to calculate a necking cross section area, and therefore a neck cross section area can be calculated exactly equal to 67.03 millimeter square. 67.03 millimeter square. I hope so. You must have understood how to use this concept. Whenever in the question there is a word is written at neck point, at maximum load, or at a point of instability, by default we have to use the equation. The true strain is exactly equal to strain hardening exponent. I hope so. You must have enjoyed. Please like and subscribe to the channel. Thank you.